Okay, now we're trying to help Simon get out of the harbour safely. Let's see if we can do that. Okay, so the first thing we have to do is to express 3 cos x minus 4 sin x in this form. So we're going to use the identity for cos of x plus alpha. So we're trying to express 3 cos x minus 4 sin x as an identical function in a slightly different form. Now, cos of x plus alpha on its own, using the compound angle formulae, is cos x cos alpha minus sin x sin alpha. When we multiply each of those terms by r, we get this. So now we've got r cos x plus alpha is 3 cos x minus 4 sin x, and r cos x plus alpha equals r cos x cos alpha minus r sin x sin alpha. So because these are identities, we can compare the coefficients of cos x here and here, and we get 3 equals r cos alpha. Here's the confirmation of that. The multiple of cos alpha here is cos x is r cos alpha, and the multiple of cos x here is 3. The multiple of sin x here is minus r sin alpha, and the multiple of sin x here is minus 4. So therefore r cos alpha must equal 3, because they're both the coefficients of cos x in these two identities. And r sin alpha must be equal to 4. I've taken the minuses into account on both sides, because they're the multiples or the coefficients of sin x. Okay, so we've got two little equations here and two unknowns, r and alpha. We can divide r sin alpha by r cos alpha, and we get tan alpha equals 4/3. So alpha is arctan 4/3, and we need to put it in radians because the question has given us that alpha is between 0 and pi over 2. When you then put alpha back into one of these, then r is 5. So we found the value of r and the value of alpha, but we haven't yet answered the question because the question asks us to express 3 cos x minus 4 sin x in this form. So it's not until we write that down that we get the final mark for that part of the question. Okay, so that's that part of the question solved or answered. Let's look at the second part now. So I've just copied that down from the previous part. Now D, we're told, is this expression here. And 0.6 cos t over 3 minus 0.8 sin t over 3 can be expressed as 0.2 times this. I'm just factorizing out the 0.2. And the reason I've done that is that this expression here is the same as that, with x replaced by t over 3. So I can replace that expression with this, with the x replaced by t over 3. So I can see now a simplified version of the equation for the depth of water in the harbour. So Simon's yacht needs a minimum water depth of 1.5. Let's see what happens when we make d equal to 1.5. So when we rearrange that by taking the 1.6 over to the other side, dividing by 0.2 times 5, which is 1, we get cos of t over 3 plus 0.927 is minus 0.1. So the calculator will tell us that t over 3 plus 0.927 is 1.671. And when we unwrap that, we get t equals 2.231, and that would be 2 hours 14, nearly quarter past 2 in the morning, which is too early because the earliest time is after 6 a.m. Okay, so there's going to be more solutions to this equation. 1.671 is the first solution, but then for cos, we say 2 pi minus 1.671 is the next answer. So the second possibility is that t over 3 plus 0.927 is 4.162. And that would give us a value of t of 11.05. In other words, 3 minutes past 11 in the morning. So that's a possible time. We also, if we want to get another answer, which we clearly do, because we're trying to look at the return as well, then we would say 1.671 plus 2 pi. That would be the next possibility. And then that gives us 7.954, which gives us a time of 21:05, 5 past 9 in the evening. But we need to know whether the tide is high between these two times or high between these two times. And I've chosen to look at a value of t10 between the first two times, and that gives a value of d. When I put 10, t equals 10 into the expression for d, I get a depth of 1.16 meters, which is too shallow. So so he can't leave at 6 a.m. And then looking at the value of t between these two times, t is 12. That's just a random value that I've chosen between those two times. And then when t is 12, the depth is 1.81 meters. So that's deep enough between these two times, the 11:03 and 21:05. So the picture, if you like, of the depth of water in the harbour for that first 24-hour period looks a bit like that. The middle point here, that's 1.6, and then the water's going up and down. We've got 3 times here, 2 o'clock in the morning, 11 and 2100, and go out too early, he's going to be in trouble. Go out a little bit later and he's going to be fine. So he must leave after 11:03 and return by 21:05. So there we are. We've answered the first part. Now we've said what the earliest time that he can safely leave the harbour and at what time it would be unsafe for him to return. Okay, there's one more bit to the question here. What are the minimum and maximum depths of water in the harbour? So coming back to the equation, this is the simplified equation for the depth of water. This will be have maximum and minimum values when that is at its maximum and minimum value. So the cos of t over 3 plus 0.927 is the only variable in this expression. So the maximum value of cos t plus t over 3 plus 0.927, the maximum value of cos of any angle is 1. So that gives us a maximum depth of 2.6, and the minimum value of the cos of any angle is -1, which gives a minimum depth of 0.6. So there we are. Quite a long question, but I hope you got on all right with that.